We need to show that these 4 points form the vertices of a rectangle. So let us begin. We will consider a quadrilateral A, B, C and D. Here we are provided with the coordinates of the vertices. So we'll suppose that A has the coordinates 4, -1. B has the coordinates -2, -4. C has the coordinates 4, 0 and D has the coordinates 2, 3. Now what we'll do? We will join the vertex A with vertex C and B with D, and that's going to give us the two diagonals of the quadrilateral ABCD. So here we have the diagonals AC and BD. So what we'll do, we'll first try to compute the midpoints of the diagonal AC. So that's very simple. All you have to do is we'll start with the x coordinate. We'll take the sum of the x coordinates. So that's -4 added with +4. This is the sum of the x coordinate of the endpoints A and C. And we're going to divide the result by 2. For the y coordinates, we use the same technique. We take the sum of the y coordinates of the endpoints. So that's -1 added with 0 and divided by 2. So that's going to give us 0, -1. So this is going to be the midpoint of AC. Similarly, we can also determine the midpoint of the diagonal BD. The BD will be, we'll start with the x coordinates. So first we'll take the sum of the x coordinates of the endpoint. So that's 2 added with -2, and we're going to divide the result by 2. And to find out the y coordinate, so we will take 3 and add it with -4, then divided by 2. So this is giving us the coordinate value as 0, -5. Now clearly we see here that midpoint of AC equals the midpoint of AD. Since they both have a common midpoint and both the midpoint have the same value corresponding to the point E, then we can say that the two diagonals AC and BD bisects each other. Now, if diagonals AC and BD bisect each other, so it's a necessary condition for it to be a triangle. However, it's not the sufficient condition. We need one more condition, and for that we will show that the diagonals AC must be equals to the length of the diagonal BD. For this, we'll have to use the distance formula to obtain the length of AC. All you have to do is take the square root. Underneath the square root, first we'll have to take the difference of the x coordinate. So that's -4 - 4, and then we're going to square this value. And we're going to add it to the difference of the y coordinate. So we have -1 - 0 whole square. So this is going to give us a value. So we have -4, -4. So that's -8. Squaring it gives us 64. And square of -1 is 1. So we get the value as square root of 65. Similarly, we can obtain the length of BD. So BD will be equals to, we'll take the square root. Underneath the square root, we need the difference of the x coordinates. So here we have 2 minus -2. So that's going to be +4, square it, and then add it to 3 minus -4, so that's going to be 7. We have 7 squared, so this is going to be equals to, now 7 squared, that's 49, added to 16, so this sum up to give us the value 65. So we also get the length of BD as 65. Now this tells us that the length of AC equals to length of BD. So this is the sufficient condition to tell us that the two diagonals of a parallelogram which bisects each other and also have the same equal length tells us that ABCD must be a rectangle, hence proved.